Our last speaker for today is Matt Hitti from Vodafone. So he's going to talk to us about 5G mobile private networks. And this is a follow-on really from the discussions we had at the July NZDIA members meeting about sort of 5G. And our emphasis on that particular occasion was to try and get some of the facts out, get rid of the ridiculous not facts that were floating around. So Matt's going to take us to the next part of the conversation, which is into the private network. So Matt, can you hear me all right?
Yeah, I can hear you, Jenny. Can you hear me?
Awesome. Very good. So over to you.
Great. Thank you. So kia ora koutou. Welcome, everyone, to my presentation. My name's Matt Hitti, and I work for Vodafone New Zealand. My role is a strategy and architecture lead in our enterprise product area. And I'm just going to share now my screen with you. So it looks like it's come through. My topic today is 5G mobile private networks. And get into it is first just to talk a little bit about what 5G is and some of the promises that 5G brings, both technically and in terms of use cases. And then I'll get in and talk a little bit about what a mobile private network is. So, got about a dozen slides and probably run about 20 minutes or so, hopefully. The first slide here is really just an overview of the evolution of cellular networks. You know, we've had 2G, 3G, 4G, and now we're getting 5G. So if we look back to the early 90s and 2G, we had basic voice calling, SMS or short message service, texting, and some machine-to-machine communications, and that was really small packets traversing the network, sending mostly telemetry data. Around about 2000, we got 3G, and you know, at that time we had feature phones, and then we were just having the advent of smartphones, and starting then to use the the internet on our devices in our pockets. Pictures seemed to work pretty well. Video, the experience wasn't great until we got to 4G. And you know, 4G really was the breakthrough for us in the convergence of smartphones and internet access. It started to be, streaming video started to be viable. And then we started seeing new business models coming, things like Netflix and Uber. And we saw a lot of disruption in this area. Now with 5G, we're really taking a big step forward yet again, where everything that could be connected or can be connected will be connected. We really expect to see the revolution of existing businesses, new business models emerging yet again. The network itself becoming more reliable. And we start talking about this tactile internet made possible by 5G and really the low latency, so that things like remote surgeries and things that rely on being able to really feel how something is moving remotely and have it move in exact lockstep will be possible. And of course, then our networks are all going to gigabit speed, even at the end user perspective. And we see 5G playing a big role in Industry 4.0, what's called Industry 4.0, and digitalization. So Sometimes in terms of the capabilities that 5G brings, we like to think about three dimensions where there's enhancements. The first is in capacity. We'll see some of the kind of the network throughput be greatly enhanced from what it is today, more than 10 gigabit data rates. End users will be experiencing up to a gigabit. We've seen in some of our Vodafone companies, say in Italy, in Milan, on their campus where they've stood up 5G, the end devices are getting up to 3 gigabits per second. So it's a lot faster from a throughput perspective. Another increase in capacity is that we'll see a lot more devices being able to connect to the network, and obviously that's important from an Internet of Things perspective, where everything's connected. We're just going to have a lot more devices connecting onto the network. The second area that we talk about is latency. And that's really, we experience latency as lag when we're performing some sort of an operation with a device. Data is being sent somewhere else. There's computations taking place, and then data being sent back. So that round trip time is really going to reduce significantly, even getting in the sub 10 millisecond range. And one of the examples that we like to talk about is, how long it takes to blink your eyes. And so that's usually around 300 to 400 milliseconds. Current networks, 4G networks, we might see, say, 50 millisecond latency. With 5G, we're seeing sub 10 milliseconds. So really that's faster than kind of, human nerves. And we see advanced areas of application and robotics, virtual reality, smart cities, autonomous vehicles getting signals so that they're able to stop in time or take action in time. And this is made possible by the new radio protocols, the way they're written, but also by edge computing, where we're going to see compute workloads that are currently taking place in centralized data centers being moved out to the edge of the network. And so really it's the end device talking to the network node, and then the edge compute node, which is maybe co-located, and then getting the return straight back. The third area on these three dimensions is slicing. This is one of the promises of 5G that's quite interesting. We're still at the early stages of figuring out how we'll slice up the network. But what this allows is for the network to be divided up and sort of tailor-made. So we can take different slices and assign different attributes in terms of throughput, latency, reliability, availability, sort of metrics, and put those on different slices of the network. And then we just make sure that we drop in, set the applications on the right slices, that are going to provide the right characteristics that they need. So this slide here just really talks about, gives a little bit of a visual representation of the increases that we see as we're progressing from 4G and different aggregations of 4G up to 4G evolution, or sometimes we're calling it 4.5G, and then on into the 5G new radio. Seeing that increase from about half a gigabit per second max a few years ago up to more than a gigabit now with 5G. And then at the same time, the latency going down significantly. Just a quick slide here on it. It's a bit of an eye chart. It's kind of complicated to look at, but trying to call out what edge computing is going to bring to the game. And it's really distributing the cloud right at the edge, allowing for the shortest path routing. we'll see, special platforms that can be stood up, specialized platforms at the edge, and services exposed via APIs. And we really see those workloads being moved right to the edge. And that keeps the traffic local to the devices, and it allows for low latency and real-time communications, and a number of other sort of computational kind of benefits. A little bit more to talk on in some of the future slides, so I'll just go ahead and move on. In terms of the use cases, typically 5G is broken up into three broad areas for application. So the first one is enhanced mobile broadband. And that's really kind of the 4G on steroids view of the world. And there we're seeing applications in HD video, 8K video, virtual reality, augmented reality on mobile devices, enhanced gaming experiences, and fixed wireless access. So there's quite a, really a push to use wireless, particularly instead of copper access, or anywhere that we need to stand up access quickly for a site. 5G wireless is going to be quite a compelling solution. The second area is in massive IoT, or massive machine type communications, and that's really where we get everything connected. Billions of machines connected together, whether it's cameras or sensors, applications in e-health, transportation and logistics, smart cities, environmental monitoring, agriculture, and automotive. So just the connected cars and all the different parts of the cars, whether it be for fleet management or safety, geocaching alerts to vehicles. And then the third area is ultra reliable low latency communications. And this is, for me, where some of the more exotic use cases come in. So we start seeing things like, autonomous vehicle assistance, robots that are working in warehouses, or even collaborative robots working alongside human beings, where need to be real careful that the robots don't hurt people by accident, and that real low latency and ultra reliability allows for that kind of control that's required. We see this in Industry 4.0, manufacturing, and we also see that mobile private networks in particular are an enabler of this type of use case, because it's got dedicated coverage, and I'll get into that in the next few slides. Okay, so what is a mobile private network? We really see that as really important for certain customers in their digital transformation journey. Their mobile private networks provide dedicated coverage for a specific geographic area, so campus areas, factories, ports, things like that. And they're superior to the existing technologies like Wi-Fi, public LTE, Tetra, in a number of ways. In particular, having licensed spectrum, radio spectrum, allows for the reliability to be higher, and having sort of a contained physical area allows for assured latency, capacity, coverage, quality of service, and availability to be guaranteed in that fixed area. So mobile private networks exist now on 4G, and we're starting to see sort of a wave of 5G mobile private networks springing up around the globe. So, and we're seeing the application of mobile private networks in a number of industries. So you can see, I don't know if you can read the slide, but upper left-hand corner is a manufacturing facility, and there's a number of use cases there, from head-mounted displays for workers and handheld computing to industrial robots working alongside to autonomous guided vehicles that are able to move things around the factory floor. Another use case that we see, or an area for mobile private network, is at an airport, where you've got information data being uploaded from the planes, also instructions being sent out maybe via augmented reality to ground crews, and then even updating the entertainment systems. In the lower left-hand corner, you can see an energy worker out sort of in the turbines, sensors on the turbine itself and the blades, as well as environmental sensors, drones that are connected on 5G private networks doing inspections for maintenance and safety, vehicle tracking. All of these things are use cases enabled by private networks. So on this slide, I just call out a few of the benefits really of having a mobile private network. First of all, as I touched on before, is having that private or reserved coverage, having assured SLAs due to this ultra reliable connectivity, and using licensed spectrum. Once again, it's not in the spectrum that Wi-Fi is, where you can get congested, by things like microwave ovens and other sorts of interference. There's high security, high speed, high connection density that's made possible by the private networks. Being able to provide quality of services, and that's possible through the network slicing, dividing up the network and providing sort of guaranteed latency and bandwidths to specific applications. And then also being able to put some local compute, edge computing, which enables low latency services, but also allows, you can have a completely isolated air-gapped mobile private network. And that kind of speaks back to the high security, being able to really ring fence the data that's moving within that network. It's also possible to have a hybrid network that's private, but also connected to the internet and having access out. Okay, so I touched on a little bit before, but some of the areas where we're seeing our customers considering moving to mobile private networks are factories, utilities, ports, oil rigs, mines, and digital offices. In the port area, we're seeing a number of use cases, from drone inspections to remote control of cranes to video analytics for safety purposes, making sure the workers have all their PPE on that's required. Things like asset tracking of containers and equipment around the port area. And then we're seeing some as well in the energy space, where the legacy wireless networks have been replaced by 5G private networks, and it's really allowing for resolving issues, lowering the downtime. Okay, this is just a sort of a grouping up different use cases that we see. So in Industry 4.0, we see manufacturing and industrial services, drivers to take up private networks, mobile private networks, or replacing Wi-Fi systems if they're coming up for replacement, PMR replacement, digitization, health and safety drivers, operational efficiency and automation. And then we're seeing connected, basically people, places, and things, workers for safety and for augmentation of their own skills, wearing goggles and sensors. We're also seeing infrastructure being connected up to provide operational data, and then location and tracking. It's just keeping track of where things are moving around a space. And then last but not least, I've got sort of a technical slide here. Oops. Back up, of what the main components of a mobile private network are. In the middle, the blue, the base capability, we've got the radio access network. So that's the antennas, the base stations, and the spectrum that's used, and that's connecting out to SIM cards, and in the future, all kinds of different modules. There's a lot of work going in development in that area right now. And the radio network connects to the mobile packet core, and that's where everything sort of gets routed together. The management platform hooks into that and allows visibility of what's happening there in that network and configuration. And then we're able to, from the packet core, route data out to MEC. So that's the multi-access edge computing or mobile edge computing nodes, either on-site or off-site, and then connect it through out to local area networks, wide area networks, or to the internet for broader sort of capability. So that's me, about sort of, 22 minutes in. Those are my slides. Got some time for questions.
Hi. Right, Matt. I'm trying to work out where that photograph was taken.
Okay, yeah, what's your guess?
Such a beautiful spot. So I'm thinking Devonport, or is it Auckland, or is it Wellington?
It's Wellington.
Wellington.
I'll give you a hint. Yeah.
Who'd have thought that Wellington could look that good? So
it was a beautiful day. That's just in Titahi Bay, overlooking that's Mana Island in the back.
Right. Good photograph, nice bench, family look happy. It's good. So it's good. So now I'm looking on the chat to see if there's any questions coming through. So one question we do have is so your presentation followed on from presentation from Vaughan at previous event where we were doing the debunking the 5G myths. Are you seeing an end to the ridiculous and more fact-based stuff, or is it getting worse?
Well, I think it's a bit of both, actually. On the one hand, people raising concerns, and you kind of have to acknowledge maybe that's coming from a good place, and they're concerned about safety. On the other hand, I think we're starting to see more and more just how important going back to the facts and the science is, and I feel that there's a growing awareness of that, and kind of understanding how radio networks work, and within the electromagnetic spectrum sort of types of energy that are safe for people, and types that are actually dangerous. So I feel like they're sort of both continuing in parallel. It's quite an interesting phenomenon, but yeah, it's sort of if it doesn't feel like the journey's over yet, that's for sure.
Yeah, no, absolutely. So I think on that note, I'm going to say thank you for being our last and excellent speaker